students, today we will be learning about the concepts of integrals. So basically the chapter integral comes after we have finished the differential calculus. Okay. Now this integral calculus is mostly based on two things, which are indefinite integration and definite integration. Now to understand these two things, we need to take a practical example of how differential and integral calculus work. So what we can do is we can consider a y-axis and an x-axis. Okay. So in y-axis, let us take a very common example of distance and time. The distance is represented in y-axis as a function of time. Time can be represented in x-axis. So now, if I have a function which represents the path of an object, okay, so the function, suppose it's a curvy function, okay, so what do we do in differential calculus? To find out the instantaneous velocity of that particular object, what we can do? We can just differentiate the function. And if we want to find out at what point, what is the instantaneous velocity of that object, what we can do? After solving for its derivative or the gradient, we can just put in the value of time. That is the most common idea of differential calculus. But what do we do in integral calculus? Just the opposite. In differential calculus, we have been given the distance as a function of time, and velocity can be found by differentiating the distance, that is our main function. Now if we have been given the instantaneous velocity as a function of time, so using the integral calculus or using the process of integration, what we can do is we can find out the position of that object. So distance or the position of the object, time and velocity, these are the very common things that we have studied in class 5 or 6. The relation between them is quite known. So if we want to find out the position of any object, if we have been given the instantaneous velocity, which is nothing but tangent, which is nothing but equation of tangent to the given function. Okay. So in integral calculus, what we're gonna do is we're gonna find out the position of any function if we know the slope of that particular function. Okay. In the example that we took, if instantaneous velocity is given, we can find the position of that particular object. Now, this is the brief idea about indefinite integration. Indefinite integration, what do? We already know the various areas of very specific shapes. For example, the area of rectangle is given by length times breadth, the area of circle is pi r square. But if we have a curve in x-axis and y-axis, then how to find the area under the curve? Area under the curve. In that case, what do? Is we apply the process of definite integration. Now, to take a common example, you might have learned in physics as well. In the chapter thermodynamics, what do? Is we take pressure on the y-axis, volume on the x-axis, and when we draw a graph or a curve, that curve and that area under the curve in your chemistry represents work done by any process. If the curve is defining a process, and the area under that curve will be defining the work done by that process. Okay. So this is a very, very common example that we can take to understand definite integration. So what is the value of finding definite integration in the first place? So that area under the curve, this is not just an area, it may represent work, it may represent terms of temperature and entropy graph. So what is mathematics? In a very brief sense, I can say that mathematics is a tool to understand science, how science works. And science, it consists of all the things, it's chemistry and biology, right? So to understand all these things, we need a very, very strong tool, and this tool is maths. And we have definite and indefinite integration to work our way out through these through the science, so that we can understand the science in a more better way. So this was a brief introduction about indefinite and definite calculus. We'll do the rest in next.